lines 9, 10, and 11 are a little different than the other ones we've done so far because on these you're working backwards a little bit. So for example, as we take a look at lines number 9, you're given the bearing, you're given the slope angle, and you're also given the true length. Excuse me. So from that information, you've got to find the lines. So as I take a look at the first one, line AB, I can see that it's going to go due west. So I know that my bearing is in the horizontal plane. So that means that the line starts here in the horizontal plane at line AH, and it goes west. I don't know exactly how far yet, but I know that it goes west. So since this line is parallel to the frontal plane, then that means I'll be showing my true length in the frontal plane. Since I'm showing the true length in the frontal plane, I can also see the slope because it's an elevation. So I can use this 30-degree slope angle and this 17mm true length to complete my view. So if I make sure my polar angle is set to 30, then I can simply draw a line starting at A. I know that it goes to the left by looking at the top view. It's going to the west, so I'll make sure I'm locked into my 30-degree angle here, go a distance of 17 and enter, and there is point B. And now I can just simply project that point up and then either trim or redraw this line to show the line in the horizontal plane. As I look at the second one here, I've got point C, and I know that it's going due south, so I'm going to draw a line from CH south. I don't know exactly how far, but I'll just draw a line in for now. And if the line looks like this in the horizontal view, then there's really only two choices for the front view. It's either going to show up as a point if it's a perfectly horizontal line, but I know that it's not. I've got a slope, so it's also going to appear as a vertical line in this view. Now both of these lines are parallel to the profile view. So if I were to construct a profile view, this is where I'm going to see my true length. And again, not only is it a true length, it's a true length elevation, so I can apply my slope to it. So I'm going to draw point C in first. So there's my ray, here's my offset value, and that'll be my first point. So that's point C. And then I can now apply my slope to this view. So as I look, I've got a slope of negative 1.2. So that means if I have a run of 1, I have a fall of 1.2. So I can draw out some construction lines here. For example, a line that goes over 1 and down 1.2. And that would work. Those lines are so small though, I'm going to use 10 and 12 because that would be the same slope. So if I have a run of 10 and a fall of 12. So I'll draw a line of 10, and then I'll bring that down 12. So that'll give me basically the vector that I need. So if I draw a ray now from point C running through the point I just created, that gives me the slope that I'm looking for. Again, this is my true length view, so I can also measure the length of the line, which in this case is 35 millimeters. There's a few different ways I can do that. I like to draw a circle that starts at this point and has a radius of 35. And that will give me the point that I need to trim with. So I can trim using this circle as my cutting edge. And there is the line. But then don't forget to project those back to the other two views. So point C now needs to extend, or excuse me, not point C, but point D needs to extend down. Then also the one that people often forget is I now need to apply this offset value up here to the horizontal view. And I can go ahead and trim that one out. And again, proper labeling of hinges and points, etc. will help complete that. So the third one here, as I take a look at what I've got, I see that my bearing is north 60 degrees east. I'm going to have a grade of 75% and a true length of 50 millimeters. So I can show my bearing in the horizontal plane. So I'll start with a line that's north 60 degrees to the east, which would be the same as 30 degrees up from 0. And again, I don't know how long this line is because this isn't going to be the true length. Where I am going to show the true length is in the next view. So if I create a hinge parallel to this, I can have a horizontal, or excuse me, an auxiliary elevation view since I'm hinged off of the horizontal. There I can apply my slope. So I'm going to draw a line parallel to this line that I created. Then I'm going to project point X across, and then go 2 views back for my offset. Here's my X offset. There we go. Then I'll place a point. All right, so that's point X in this auxiliary view. In this auxiliary view, I can apply my slope because I have an auxiliary elevation. So it's going to show my true length and my slope. So my length is 50 millimeters. My slope is a positive 75%. So I can look at that a few different ways. I could say if I had a run of 10, I'd have a rise of 7.5. Or I could say I've got a run of 4 and a rise of 3. Either of those would make sense. So I'm going to use a little bit of offsets. Now the thing that's tricky about this is run is parallel to the horizontal plane. So this direction would be my run. And rise is perpendicular to the horizontal plane. So I'm going to, I'll use 3 and 4. I'm going to offset a run of 4. And then a rise of 3. And where they meet, that will show me where my slope is. So I'll draw a ray from my original point through that point. That gives me my vector. And as I did on the earlier one, I'm just going to draw a circle with a radius of the true length, in this case 50. And now I've got my second point. So now I can trim out the rest of that one, clean up everything. Of course, do my labeling. But then I'm going to take this point perpendicular to the hinge. That now shows me where point Y is in this view. So I can trim that one out. And then now I can take that point and project it straight down. And then I'm going to go 2 views back for my offset, 1, 2. So this offset value right here is what I'm looking for. Perpendicular. So I'll just extend this over so I can find that intersection. And that will be point Y here in the front view. And again, proper labeling of hinges and points to finish that one out. So that's kind of the thought process when you're working backwards on these. As we look at lines number 10, you're going to do a little more working backwards. This time you're going to be asked to classify lines. So are they frontal, horizontal, profile, vertical, or oblique? And then you're going to be asked to measure the true length and the bearing and the grade as a percent. So a couple things to help you get started on this one. The first thing you're going to do on this one is locate points A and B in the horizontal plane. So if I project A up and A perpendicular where they meet, that's point A. Then I'm going to do the same thing with B. So B perpendicular, B straight up, and there is point B. So I don't have any true length lines, no parallel relationships, and I know I want to find the slope, so that means I want to create an auxiliary elevation view. So that means that I'm going to hinge off of the horizontal plane. So I'm not going to go the rest of the way through this. I'm just going to show you that your next step then would be to create a hinge parallel to this line here, project both points across, and use your offset values to find the true length. Once you have the true length out here, then you'll be able to measure it with your aligned dimension tool. You'll be able to find your slope as a grade percentage. And then of course the bearing, that just comes from the horizontal view anyways. And as you look at this one down here, this one is true length. And so to figure out what it would look like in the front view, for this to be true length, the front view needs to be parallel to this line. Just like if I had a line, I would construct this hinge parallel to it to get my true length. So the problem with this one is that we don't really know where this true length line is. And the truth is it can go anywhere in here. Just like if you have the line and you can draw this hinge wherever you want as long as it's parallel, this line can be anywhere within here. So I'm going to use my snap to nearest, shift right click nearest, and just pick a point here on this line, and then I'm going to go perpendicular to the other side, and that will be my line. Then I'll be able to project those 2 points straight up to my horizontal plane, offset values from here. So here's D and C. So that will give me a line that looks like this. Again, proper labeling of everything. But as you take a look at this, I've got a true length line here, but it's hinged off the frontal plane, so that makes it an auxiliary inclined view. So I cannot measure slope here. So after finding the horizontal view, you now need to construct one more view parallel to this line. That way you are creating an auxiliary elevation. And in this view, you can find the true length, which it should measure the same as this one. But it's this view where you'll actually be able to measure your slope as a grade. And of course, remember the bearing is always coming from the horizontal plane here. The last one, lines 11, very similar. You are just to construct the rest of the views and find the values. So as I look at the first one here, I've got a point view, R1S1, and a true length of 35 millimeters. So in order to have a point view, that means this hinge must be perpendicular to the true length line. So I'll begin by drawing a ray from this point perpendicular to the hinge. And similar to the previous drawing, I don't really know where this line is in here. I just know it belongs in here somewhere. So what I typically do will be maybe create a perpendicular line and then offset that to true length of 35. Then I've got my line in here. So I can either trim or redraw that line. In this case, I'll just trim. And there is my true length line. So now that I have those 2 points, I can project those up and then get my offset from this view here. And then I've got my horizontal view. So now that I have my horizontal view, I can figure out what my bearing is. My grade, here I've got an elevation view that shows true length, so I can find it here. And then of course you can classify it. The next one down, the path on this one you want to take is create your horizontal view first. So if I were to take X and Y back across this hinge, and I want to know how far behind the frontal plane this line is, well I can see that over here. So I'm going to offset one of these endpoints perpendicular to the hinge, and that will give me the line XY in the horizontal plane. So now I'll be able to determine what the bearing is. But then also, since this is parallel to the front, this is parallel to the front, my true length elevation will be in the frontal plane here. So once I have that, then I can go ahead and calculate my slope and my true length as well. Now on the first exam, there won't be any questions like this where you're working backwards. It'll be more like the earlier lines drawings that we were doing, where you're just finding the true lengths and finding the point views and finding the slopes and bearings. But this is a good exercise to make sure that you understand what all of these values are.